In this video, we're going to be talking about hypothesis testing using a single sample. Sharing prescription drugs with others can be dangerous. Is this a common occurrence among teens? Or the National Association of Colleges and Employers stated that the average starting salary for students graduating with a bachelor's degree in 2010 is $48,351. Is this true for your college? How do we answer questions like these using sample data? In Chapter 9, we used sample data to estimate the value of an unknown population characteristic. And in this chapter, we're going to use sample data to test some claim or hypothesis about the population characteristic to see if it is plausible. To do this, we use a test of hypothesis and test procedure. So what is a test of hypotheses? A test of hypotheses is a method that uses sample data to decide between two competing claims or hypotheses about the population characteristic. So, is the value of the sample statistic a random occurrence due to natural variation? So is it one of the values of a sample statistic that are likely to occur? Or is a value that would be considered surprising? So is it one that isn't likely to occur? Hypothesis statements are the null hypothesis, which we denote by H sub naught, and is a claim about a population characteristic that is initially assumed to be true. The alternative hypothesis, denoted by H sub A, is the competing claim. You're usually trying to determine if this claim is believable. So to determine what the alternative hypothesis should be, you need to keep the research objectives in mind. The hypothesis statements are always about the population, never, I repeat, never about a sample. Let's consider a murder trial. What is the null hypothesis? This is what you assume to be true before you begin. So our H sub naught is that the defendant is innocent. So what would be the alternative hypothesis? Here you are trying to determine if the evidence supports this claim. So our H sub A is that the defendant is guilty. So to determine which hypothesis is correct, the jury will listen to the evidence, and only if there is evidence beyond a reasonable doubt will the null hypothesis be rejected in favor of the alternative hypothesis. If there's not convincing evidence, then we would fail to reject the null hypothesis. Now remember that the actual verdict that is returned is either guilty or not guilty. We never end up determining the null hypothesis is true, only that there is not enough evidence to say that it's not true. So we make one of two decisions. We either reject the null hypothesis or we fail to reject the null hypothesis. So either guilty or not guilty. What about the form of hypotheses? So the null hypothesis, or H sub naught, is the population characteristic equaling the hypothesized value. The null hypothesis always includes the equal case. This hypothesized value is a specific number determined by the context of the problem. Now, alternative hypothesis, or H sub A, is the population characteristic greater than the hypothesized value. Notice that the population characteristic and the hypothesized value are the same as the null hypothesis. The symbol that we use is actually determined by the context of the problem, so it doesn't have to just be greater than. It could also be less than or not equal to. So these are considered one-tailed tests, are greater than and are less thans. because you're only interested in one direction. The not equals to is considered a two-tailed test because you're interested in both directions. So we're going to go ahead and we're going to practice writing some hypothesis statements. So let's look at our first example. Here we have sharing prescription drugs with others can be dangerous. A survey of a representative sample of 592 U.S. teens ages 12 to 17 reported that 118 of those surveys determined or admitted to having shared a prescription drug with a friend. Is this sufficient evidence that more than 10% of teens have shared prescription medication with friends? So we want to state the hypothesis here. So we need to ask ourselves, what is the population characteristic of interest? And it's that the true proportion P of teens who have shared prescription medication with friends. So what is the hypothesized value? Yeah, it's the 10% or 0.1. So what words indicate the direction of the alternative hypothesis? And it's the words more than. So our H sub naught will be P is equal to 0.1, and our H sub A will be that P is greater than 0.1. Let's take a look at another. Compact fluorescent, or CFL light bulbs, are much more energy efficient than regular incandescent light bulbs. EcoBulb brand 60-watt CFL light bulbs state on the package, average life 8,000 hours. People who purchase this brand will be unhappy if the bulbs lasted less than 8,000 hours. A sample of these bulbs will be selected and tested. So what do you think is the population characteristic of interest? That's right, we care about the true mean, or the mu, life of the CFL light bulbs. So what is the hypothesized value? That's right, 8,000 hours. And what words indicate the direction of the alternative hypothesis? Yeah, less than. So I want you to take a moment and I want you to write the H sub naught and our H sub A. So I want you to write our null hypothesis and the alternative hypothesis for this example. So go ahead and push pause, and when you're done, push play, and let's see if you were right. So here, our null hypothesis, or our H sub naught, is that mu is equal to 8,000. And our alternative hypothesis, or our H sub A, is that mu is less than 8,000. Let's look at another one. Because of variation of the manufacturing process, tennis balls produced by a particular machine do not have the same diameters. So suppose that the machine was initially calibrated to achieve a specification of a mean of 3 inches. However, the manager is now concerned that the diameters no longer conform to this specification. If the mean diameter is not 3 inches, production will have to be halted. So let's go through this one. All right, let's have you do this one on your own. So I want you to write the hypothesis, the null hypothesis, and the alternative hypothesis. So again, the null hypothesis and the alternative hypothesis. So go ahead and push pause, and when you're done, push play, and we'll go through it and we'll see if you were right. So in stating our hypothesis, we first want to ask ourselves, what is the population characteristic of interest? And in this case, we're talking about the true mean, or the diameter of the tennis balls. So what words indicate the direction of the alternative hypothesis? That's right, it is not. So our null hypothesis is going to be that mu is equal to 3, and our alternative hypothesis is that mu does not equal 3. Let's look at some other examples. For each pair of these hypotheses, we're going to indicate which are not legitimate and how come. So in our first example, we have that our null hypothesis, our H naught, is that mu equals 15. And our alternative hypothesis is that mu is greater than or equal to 15. So is this legitimate or not legitimate? It's not legitimate because it can only be greater than for alternative hypothesis. Our only choices are greater than, less than, or not equal to. Let's take another example. Here we have our h sub naught is that x bar equals 4, and our h sub a is that x bar is less than 15. So is this legitimate or not legitimate? This one is also not legitimate because you must use a population characteristic, and x bar is a statistic. It's from a sample. Remember, we only talk about the population. In this example, we have h naught is that p equals 0.1, and our h sub a is that p does not equal 0.1. So is this legitimate or not legitimate? This is legitimate. It has everything that it needs and nothing that it shouldn't. Let's look at another example. So here we have our h naught is that mu equals 2.3, and our h sub a is that mu is greater than 3.2. So is this legitimate or not legitimate? It's not legitimate because you have to use the same numbers as in h naught. And here, our h naught had 2.3 and our h sub a is 3.2. Let's do one more example. In this example, our h naught is that p can't equal 0.5. And our h sub a is that p equals 0.5. So is this legitimate or not legitimate? It's not legitimate because your h naught must be equal. Every time your null hypothesis will always have to be equal. And so that's how you can write hypotheses, specifically your null hypothesis and your alternative hypothesis. And that's how to determine if hypotheses are legitimate or not legitimate.